right, lesson or unit 7, exponents in scientific notation. In your words, what is an exponent and why are they helpful? Lucas.
An exponent is basically a number that you basically like times it by that many times.
Okay. So why do we care?
It makes it easier.
Yes, it's a shortcut, a shorthand way of writing something. Especially really large and really small numbers, which is where scientific notation comes in. Chances are in science you've seen numbers in scientific notation. I think it's measured really large or really small. Scientific notation is super helpful instead of writing out those large or small numbers. So you're going to see, we're going to talk about those things. Again, about half of it is exponents, rules of exponents, multiply, dividing, adding, subtracting, and then we get into scientific notation, which is really large and really small numbers. Okay, about half and half. Again, you can expect a quiz probably after 8 or so, somewhere in there, depending on what day of the week it falls. Okay, so if we look at the first part of the problem here, it talks about which one doesn't belong. Okay, well, pretty sure the one that doesn't belong would be the one that doesn't equal the same as everything else. So do you see one that stands out there that doesn't equal the same as everything else? Taylor, which one do you think doesn't belong? Why? Okay, that's not wrong. 8, because it's the only one that doesn't have an exponent. Okay, again, you defend your answer there. I would accept that. Ian? Bottom right. Why? The only one that's not simplified. It's got a multiplication dot in the middle there. Gavin?
2 to the third power.
2 to the third power. Why?
Because it's the only one that is third power.
It's the only one that has a third power. Yes. Okay? It's the only one that hasn't been chosen yet is the one that I would have chosen. Somebody already said 8.
Oh, third to the second.
Why?
Oh, that one because it's not.
It's the only one that doesn't equal 8.
It's a 3.
Okay? Now, what exponents mean and where people get confused is they'll say 2 times 3 is 6. That is not the case. That is the most common part incorrect. And I guarantee somebody will do that on their homework today. It's not 2 times 3. It means 2 3 times. Okay? 2 to the third power. And that, of course, is 8. This one is not 3 times 2. It means 2 3s. Which is 9. And the bottom one here is 2 2s and then another 2, which again is 8. So again, whichever one you pick, you be able to defend that. Nobody was incorrect in their assumption there. Just be ready to defend it. The other thing, when you write the exponents, make sure that is written as a little number, so I don't think that is a 52. You may think that sounds silly, but if you write it really fast, that can look like a 52 in a hurry. So let's go on to number 2. Would you read it for me, Parker, please? About Maya and Andre.
Maya and Andre found an old brass bottle containing a magical genie. They freed the genie and offered them each a magical $1 coin as thanks. The magic coin turned into 2 coins on the first day. The 2 coins turned into 4 coins on the second day. The 4 coins turned into 8 coins on the third day. This doubling pattern took 28 days. Maya was trying to calculate how many coins she would have in the memory, and instead of writing
Oh, I want you to read the next one really bad. The number of coins Maya had on the 28th day is very, very large. We're going to have Parker tell us the equation. No, we're not. Write an expression that represents the number without computing. Sometimes it'll say just write the expression, don't solve it. Please take advantage of that. That's going to be easier for you. So the 28th day, that means it's going to double 28 times. So I would write down 2 to the 28th. Okay, Parker, you could write 2 times 2 and say it 28 times if you want, but it does say the expression. That is certainly simpler. Question number 2. Andre coins lost their magic on the 25th day, so Maya has a lot more coins. How many times more coins does Maya have than Andre? Okay, so Andre only got 25 days worth. Maya got the full 28. Question is, how many times more coins does Maya have? Ian? Huh? 8? How'd you get that?
3 days.
Yeah, so 3 extra days. So he lost double each day. That would be a total of 8 times. That is exactly right. And Maya would have 8 times as many coins without those 3 days. Question number 3. Addie, would you read that one, please?
After a while, Jada picks up a coin and sees different than the others. She notices that the next day only half of the coin is left. On the second day, only 1/4 of the coin is left. On the third day, 1/8 of the coin remains. What fraction of the coin remains after 6 days?
All right, so this is the exact opposite. Sorry, I forgot there's 2 Addies at the moment. Addie, you can help answer this one then, to be fair. What fraction of the coin remains after 6 days? So how much of the coin is disappearing? Addie, I'm asking Addie. Half. Okay, and you're doing it for how many days? Gavin. Zoe, stop.
28 days.
Nope.
Or 6 days.
6 days.
Let's read the next
Right?
question.
Now it doesn't, now this is what that would look like. It doesn't say what's the expression. Okay, so that means it wants an answer. So I actually have to multiply it 6 times. So Parker, we could have you read this again. Not going to. 1 times 1 times 1 times 1 times 1 times 1 times 1, 6 times? How many? 1. Yes, 1 times whatever, that many times is 1. Wyatt. 2 times 2 times 2 times 2 times 2 times 2, please.
Oh. Like 64?
Like 64?
Yeah.
2, 4, 8, 16, 32, 64. Yeah, you can do that one. You don't need a calculator for that. Taylor. Give me the expression that would show, without computing, how many I will have after 28 days.
Oh, goodness. Sorry.
Just the expression.
So it'll be 1.
Oh, what fraction do we have?
Wait, I think I got it.
1/2.
It's like
But the 20
1/2.
1/2 in parentheses with the 28.
And you're doing it for 28 days.
Yay!
That's it.
Technically, does the coin ever disappear? It's so small and microscopic.
All right, apparently Sienna wants to do the next one.
What?
Sienna, would you read number 3?
Does the coin disappear completely? If so, after how many days? I don't feel like it will. I think it'll just end up getting really microscopic.
Will it ever disappear completely?
Well, what if it turns into an atom?
What if it
Split
gets
out?
smaller
We have to
than
figure
an
out
atom?
when.
There's actually subatomic particles, and then those particles can actually be split even more.
Exactly.
So atom is not the smallest.
So
Oh, so
So
no.
if you kept shrinking, would you ever disappear?
Will it ever disappear? Othniel, what do you think?
Yeah.
Why? Don't shoulder shrug me. You just said no so confidently.
To IU, yeah, but to actually.
Ian.
Oh, because you split it down, just you split it.
Yeah, it's always going to be in half. Will that half get super small? Absolutely. But there's still going to be half of it left.
See, it'll disappear to the naked eye, but yeah.
It will always contain half.
It's like that cheese thing.
Zoe, you just love to talk today. I don't really want to know about cheese right now. The Are You Ready? Bethany. Sienna. Shh. Okay. So here's Tyler,
58 parents.
and it wants a family tree. So from Tyler, there would be his parents. Those parents would each have parents. That would be his grandparents. And then to get great grandparents, you gotta do it one more time.
Okay, what the fuck?
Okay, so this would be our initial. This would be one generation back. There's two people there. This would be two generations back. There's four people there. This would be three generations back. That would be 8 people involved in his ancestry.
It's too far.
Okay, you can count them 1, 2, 3, 4, 5, 6, 7, 8, right? Now the question is, we say that Tyler's 8 great grandparents are 3 generations back. We just showed that. What generation back would Tyler have 262,140?
A lot.
I literally just seen this the other day.
No, you
A
didn't.
lot of generations.
Zoe, if you have something to say, please raise your hand.
It's a trick.
Parker,
I mean, it's not a trick, but like.
let's try it. Probably want a calculator for this one. 2 to what power? 2. You're gonna try 2 squared. Okay, no, I'm guessing it's gonna be more than that. 2 to what power would give you 262,000? What number did you try? Somebody share what number they tried.
13107
2 to that power? Give me that thing.
Isn't there a button?
You can't just divide by 2. It's not multiplying and dividing. All right, let's go 2. Where's the exponent at? Right here is the exponent button you're going to use. I would use Desmos because you can see it super easy. But you can use this thing. 2 to the, let's try 10th power. That's going to be more than that. 2 to the 13th power. More than that.
Let's say 15.
2 to the 15th power. More than that.
20.
2 to the 17th power. Oh, it's right
62.
there. It's one more than that. 2 to the 18th power. There it is. This button right here is what you will use. Again, I would use Desmos. Super easy. So that would be 18 generations back
That's not bad.
to have that many people.
That's my great.
Final reminder, do not think that is 2 times 6. That is 2 to the 6th power in the summary. So starting on page 10, does go to 12. There are 6 questions. Please draw an arrow on the bottom of 11 so you don't forget to do the last question. 1 through 6 for tomorrow, please. First assignment of Unit 7.